Good morning. I'm Nandini, Assistant Professor, Triple E Department, Hindustan College of Engineering and Technology, Coimbatore. The topic we are going to see today is resistors in parallel. The content of the lecture is today is introduction, resistors in parallel, one example for that, current division rule, advantages, disadvantages and application. Next slide is introduction. Practically, we will be connecting many resistors together in order to get a desired resistance. The connection of resistors can be in three different combinations. The first combination is series combination, second is parallel combination, and the last one is series parallel combination. Here we are going to see about parallel combination. If one end of all resistors is joined to a common point and other ends are joined to another common point, this combination is said to be a parallel combination. Here the voltage source is being connected between the two common points. Equivalent resistance, we are going to find the equivalent resistance of the parallel circuit. Let V equal to the applied voltage and I equal to source current. We know by Ohm's law I equal to V by R. So in this case we are going to find about I1 equal to V by R1 and I2 equal to V by R2. But I equal to I1 plus I2. I1 plus I2. Here we have this V by R1 plus V by R2. So taking your V commonly out, it is 1 by R1 plus 1 by R2, that's equal to V by RT, where your RT is nothing but R1 into R2 by R1 plus R2. Salient points, that is important points of this voltage is connected in parallel is, the voltage will be same across all the resistors, and here the current is distributed, it is inversely proportional to its resistance, and the powers are additive. The source current is equal to the sum of branch currents. These are the main important points of your. Here we have one current division rule, that is we have many more parallel resistors will be there. So we have to find what is the branch current. In order to that we have a formula said to be a current division rule. Let branch currents be I1 and I2, and also we know that the total resistance is R1 into R2 by R1 plus R2. So total V equal to total current into total resistance, that is I equal to R1 by R2 by R1 plus R2. By Ohm's law, the current through R1 is I1, where I1 equal to V by R1, that's equal to I into R1 into R2 by R1 into R1 plus R2. So cancelling this R1, so we will be getting I into R2 by R1 plus R2. Same way the current through R2 is I2. I2 equal to V by R2, and that is equal to I into R1 into R2 by R2 into R1 plus R2. We are scoring out your R2 and R2. So it is I into R1 by R1 plus R2. So the rule is, in a parallel circuit, the current in one branch is the total current times the opposite branch resistance to the sum of all the resistance. That is, the current in one particular branch is equal to the total current into opposite branch resistance to the sum of all the resistance. The parallel wiring is being applied in all electrical appliances because each one of them can be controlled individually. This type of wiring or parallel connection is done in auditorium, house wiring, etc. In case of security cameras also we use the same type of wiring. Advantages: the electrical appliances of different power ratings may be rated for the same voltage. That is, many different appliances can be connected for the same voltage. In case of any break occurs in any of the circuits, it will not be passed to the nearby circuits. It will be handled individually. Disadvantage of this parallel connection is it is complex in designing this connection. It is expensive and occupies more space. The voltage increases with decrease in resistance. Thank you.